I realized partway through the talk, I meant to give Bill an actual introduction, but I was so consumed with getting the tech right that I forgot. So maybe while we're waiting for a few questions to come in, I'll mention that some of my earliest impressions of Bill, I think I met him a couple of years ago for the first time. We were doing a chapel tutorial, and he had asked at some point about whether you could use chapel from within Jupyter, and this is something we had gotten asked a lot in the years leading up to that time, just because Jupyter was getting so popular. And our standard answer was something like, Jupyter's not so good with compiled languages, and even the C implementations in Jupyter are not that great and such. And then I think by the end of the tutorial that we were giving, Bill had actually mocked up a chapel in Jupyter code block, which was really impressive and exciting. And I think what you've seen here in Arkouda is an obvious extension to some of those principles, trying to leverage HPC in an interactive setting. So with that, Bill, I don't know if you found the Q&A tool. There are a couple questions that have come in. The first one I think you guys were starting to address in the chat, but I think it's probably worthwhile enough that other people might be interested in the answer as well. And that was from Brian Dolan. He asked, if he's attached to Arkouda and he uses something like a scikit learn regression, he believes that scikit delegates the linear algebra to Numpy, and does that mean that it's automatically going to start just running over Arkouda, or does he have to do something different to call Numpy directly, or how does that play out?
Yeah, thanks, Brian. This is a really good question, and I need to make it clear that Arkouda is not actually a drop-in replacement for Numpy. In the first couple of months that we were building Arkouda, we maybe had that dream, but then we realized that a lot of packages in the Python ecosystem use Numpy in a kind of a leaky way, and they sort of assume the ability to go over and actually mess with the memory that backs the Numpy array, which of course, you can't really do that across this server client connection. And so we decided to not try to make Arkouda a drop-in replacement for Numpy, although, if a package does use the abstraction, does respect sort of the abstraction of the Numpy array, then it could, in theory, be amenable to just replacing Numpy with Arkouda. I'm not going to say that it's going to work right out of the box, but I don't know if I haven't looked at the scikit-learn regression functions and how well they respect the abstraction of Numpy arrays. But if they do, then there's a good chance that we could take a lot of that source code and just replace Numpy with Arkouda. And we would of course have to look at if there's any methods that we're missing that we need to implement. But that's sort of how we envision things going. Is you would have to either re-implement something or take the source code and at least follow closely what the Numpy based source code has done, and make sure that you're calling primitives that are available in Arkouda. Unfortunately, it's not just a drop-in.
Bill, let me go out of order here and go down to Rich Vudick's question, because I think it's topically related, and maybe you've already answered it, but just to give you a chance. So Rich asked, how important is it in the design of the Arkouda API to maintain Numpy or pandas interfaces?
That is a great question. So we've actually already broken we've broken the pandas interface, in terms of how group by works, mostly because we don't have a data frame class. So the pandas API is already something that we're treating more as a loose guideline rather than a strict standard that we need to conform to. For Numpy, we've tried to stay pretty close to it. The exception that I mentioned in the talk is that we have this function called coargsort, which does sort of the opposite thing of Numpy's lexsort, just because it works better with the data frame abstraction that we're using. But I think that in the rest of our sort of Numpy-like functions, we have tried to respect the Numpy API and names for things. As to how important it is, I think it's important for Numpy because it will enable that kind of composability and probably reduce the amount of work that people will need to put in order to port things like scikit-learn functions over to using Arkouda. For pandas, I don't expect that it will be very important, for developers in order to have a pandas API. I think for data scientists, it's nice to have functions that are named familiar things. But we're going to do there are some things in pandas that we don't really like the design of anyway, and so we're going to, I guess, feel somewhat free to challenge or correct course when we deem that necessary.
Okay, great, thanks. Let's go to Michelle Strauss' question next. She asks, what kind of input data formats does Arkouda currently handle, and what data formats are important for the future?
Good question. Yeah, so currently Arkouda only accepts one input format, which is HDF5. And that's for reading from disk. It of course interoperates with Numpy arrays. So if you have small data that you want to use in Arkouda, you can actually read it in Python using sort of the rich set of tools that are available for I/O there, and then you can send it over the socket to create an Arkouda array out of it. But if you have big data that you want to, that lives on a parallel file system, let's say, and you want it to stay in distributed memory, it has to be in HDF5 right now for Arkouda to ingest it. So what we do is, because nobody delivers you your data in HDF5, so what we do currently with all of our data sets is we have a Python script that sort of runs in the background all the time and is constantly converting the CSV or JSON files that we get into HDF5 format. And it's just sort of constantly doing that in the background, and it doesn't take a lot of resources, at least in the setup that we have to do that. So that's the way we've been doing it now. Have an ingest script that will do the initial conversion to HDF5, and then keep working in HDF5 when you're using Arkouda. We haven't thought to, we haven't made definite plans to add more ingest formats or I/O formats, because there's just so many of them, and we're not sure if that's really the place that Arkouda can offer value. But that's something that we would lean on the community to sort of nominate things for us and dictate the importance of those kinds of features. Yeah, and then I guess one other thing I'll mention is that for most of the users that we've worked with as data scientists, their workflows, it's important for them to be able to read in a lot of data fast, but most of them do not have the need to output a lot of data. So there's in a typical exploratory analysis, the users that we've seen load up a large data set, do data science on it in memory, and then come away with either just a conclusion in their minds, or perhaps a small set of results that fits easily into single node Python. And so they can use the Numpy interoperability to get results out, and they don't really have to worry about using Arkouda natively to export or save data.
Okay. I'm going to go a little bit out of order here. A couple of people are asking questions about how easy or hard it is, or what the process is, maybe even, of adding a new primitive operation to Arkouda.
Okay, yeah. So there is a little bit of information about this in the Arkouda documentation and the README that's available on the GitHub repo. It does take a little bit of getting used to. Especially if it's a primitive that you want to write in Chapel to execute in the Chapel server, you need to, of course, write the Chapel code as a module. and you need to learn how to sort of maybe examine examples from the Arkouda code base to learn how to do that array lookup in the distributed object store and hook into the dispatcher. But once you learn that, there's not a whole lot of code necessary to hook into that system. And then the only other thing you need to write is the client side interface to call your primitive, either as say a method or an operator overload on the PD array class, or as an Arkouda module function. Yeah, so there are probably 3 or 4 things that you need to write in order to add a new primitive to Arkouda, and there is some learning curve. But I would encourage you to check out the documentation, and I forget what the section is called, but there's a section that walks through a sort of a template for that.
So Bill, let me jump to Brian Dolan's question. I think it's kind of follows on. He was curious how he would use Arkouda to do a higher level function like a linear regression or an SVM. And I guess you could view this as like, should this be new Python code that calls into existing Arkouda stuff, or does it involve writing new Chapel code, or could it be either one?
Well, so we've actually been sort of surprised by the users that on our team that we work with, sort of on a daily basis, at how they have really not waited around for us to implement new primitives on the Chapel side. They've taken Arkouda and used the client functions that are already available to compose these kind of things like, actually somebody did do matrix multiplication, sparse matrix multiplication entirely in Arkouda. It was a little bit hard to read. It was kind of opaque, but I think we're getting to the point where there's sort of this critical mass of primitives that you can actually do a lot of these things with the functionality that's already available in Arkouda, sort of above Arkouda in the stack. I don't know off the top of my head if everything necessary for like SVM is available, but I think what will help is as we progress towards getting more sparse linear algebra explicitly in Arkouda, that will probably answer a lot of the mail needed to compose things like SVM out of Arkouda primitives.
Okay, thanks. I'm going to go to a question from Joy Montero, I hope I'm pronouncing that correctly, who asks, the ability to compile a Chapel library as a Python module will probably be full-featured eventually, probably relating to something I mentioned in my kickoff talk this morning. Will this client-server interface that Arkouda uses today still be needed once that Chapel Python interop is full-featured?
Yeah.
I'd be happy to help with that too.
Sure.
I'll mention from my perspective, we've been using Arkouda as a motivating example. Like, we don't think most people will necessarily want to go to the lengths that Arkouda has in order to call between Python and Chapel. So we have a goal internally to create a version of Arkouda that just uses the Chapel interop features and doesn't use any explicit client server stuff over ZMQ. But as I understand the Arkouda use case, and Bill, you should correct me if I'm wrong, but you guys sometimes want an Arkouda session to persist across like multiple users or multiple Python programs potentially. Whereas I think the Chapel sort of built-in interop, at least in its first draft, will be more kind of single Python program, single Chapel program, single user types of scenarios, which means it may not be as kind of rich or robust as what you might ultimately want. Does that lead you anywhere?
Yeah, I think that's accurate. We really are targeting persistence, especially with that distributed object store that's part of the Arkouda server. And of course, we'd be really happy if if Chapel natively sort of put us out of a job in a lot of respects. That we would be a-okay with that. And in part because it's less to maintain as a separate project, but also because it would probably be faster and more efficient just doing things directly in Chapel. So we're excited for things to go that direction, you know, but of course, for now we have something to fill the gap.
Okay, great. I'm going to put a pair of questions together here. So Brian Dolan was asking about, you mentioned hypergraphs, and there will be a talk later on today for those who didn't see the agenda on the Chapel Hypergraph Library, CHIUW, out of PNNL. So Brian was asking, have you done a project where CHIUW uses Arkouda, or maybe Arkouda exposes CHIUW would be another way of viewing it. And then Cliff Jocelyn, who's part of the team developing CHIUW, asks whether 2D or ND arrays are supported yet in Arkouda. Did you get all that?
Oh, sorry, my connection cut out a little bit, but I think I got the gist of the sort of combined question. We have actually had, you know, several conversations with Cliff and Emily working on CHIUW, and you know, this question of where should CHIUW sit relative to Arkouda in the stack. You know, should CHIUW be a set of primitives that are exposed by Arkouda to Python, or should like Hypernetwork X be using Arkouda primitives to get distributed execution? You know, those are still ongoing conversations. Cliff has pointed out in the Q&A that in order for the second scenario to work, we would need 2D or higher dimensional arrays supported in Arkouda. And right now we don't have support for higher dimensional arrays. It's not it's not in principle that hard to do higher dimensional arrays in the way that Numpy does them in a dense fashion. Because what Numpy does is it has a one-dimensional block of memory that it puts a multi-dimensional view on, and so the multi-dimensionality is all in the metadata. But I think what something like Hypernetwork X would require is sparse multi-dimensional arrays, and that's a little bit harder. But I think the sort of multi-array group by operations that Arkouda already supports, and thanks to Elliot supports in a performant way, provide the computational machinery for doing sparse multidimensional arrays. It's really now just more of a software design and development question of how to expose that to users in the best way. And that is perhaps a little over my head. I'm not really a software developer. I'm more of a scientist. But this is a place where we would love for people in the community to get involved and you know, both make their voices heard in terms of guiding how we do it, and also even contribute code. So that's just a plug for for people to check out the GitHub repo.
Okay, great. That brings us to the end of our keynote session. If you have other questions for Bill, you could probably chat to him directly or contact him offline. But Bill, thanks very much for giving our keynote today, and for all the work that you and Mike and crew have done on Arkouda. It's been exciting for us to see on the Chapel side, and I get a lot of excitement from people in the community as well, which is always nice to see. So thanks again for speaking today.
Good, thank you for inviting me, yes.